You should remember these top 5 GMAT math formulas in order to excel in the quant section. The Pythagorean theorem. There's a reason this is the most famous theorem in mathematics. This remarkable theorem is one of the most versatile and highly adaptable formulas in existence. Of course, I'm sure you remember that it says for any right triangle, a square plus b square is equal to c square. Of course, if any question gives you two sides of a right triangle and asks you to find the third, you will use this formula. Let us look at a couple of problems to show its other guises. Area of a triangle. As you may remember from high school, area is equal to half into base into height. If you are having trouble remembering this, simply remember that a rectangle has an area of A is equal to BH and that a triangle is half a rectangle. Averages and sums. Everyone knows how to find an average, but the power of this formula is often underestimated. We know average is equal to sum of the items by number of items. We can also write this as sum of items is equal to average into number of items. This latter form can be powerful. For example, if we add or subtract one item from a set, we can easily figure out how that changes the sum, and that can allow us to calculate the new average. Also, if we are combining two groups of different sizes, we can't add averages, but we can add sums. Distance and work rate. A rate is how fast something is growing, changing, or being performed. The overarching rate formula is amount is equal to rate into time. When the rate is a speed, this simplifies to the familiar formula distance is equal to speed into time. In questions about speed, especially where an object travels at one speed for a while, then at another speed, keep in mind that you never find the numerical average of two different speeds. If the question asks for average velocity for the whole trip, then you add the distances from both parts of the trip to find the total distance and add the times of both parts of the trip to find the total time and use those and the formula above to calculate the speed. When the rate is a rate of work being done, then when two people work together, their combined rate is the sum of their respective individual rates. Make sure what are you adding are the rates and not anything else. Permutations and combinations. A permutation is a possible order in which to put a set of objects. Suppose I had a shelf of 5 different books and I wanted to know in how many different orders can I put these 5 books. Another way to say that is 5 books have how many different permutations. In order to answer this question, we need an odd math symbol, the factorial. It's written as an exclamation sign and it means the product of that number and all the positive integers below it down to 1. For example, 4 factorial is 4 into 3 into 2 into 1 is equal to 24. So number of permutations of n objects will be n factorial. Combinations. Combination is a selection from a larger set. Suppose there is a class of 20 and we are going to pick a team of 3 people at random and we want to know how many different possible 3% teams could we pick. Another way to say that is how many different combinations of 3 can be taken from a set of 20. This formula is scary looking, but really not bad at all. If n is the size of the larger collection and r is the number of elements that will be selected, Then the number of combinations is given by number of combinations is equal to n factorial by r factorial into n minus r factorial. Again, this looks complicated, but it gets simple very fast. In the question just posed, n is equal to 20, r is equal to 3, and n minus r is equal to 17. Therefore, number of combinations is equal to 20 factorial by 3 factorial into 17 factorial. To simplify this, consider that 20 factorial will be equal to 20 into 19 into 18 into 17 into product of all the numbers less than 17, which is written as 17 factorial. The neat little trick allows us to enormously simplify the combinations formula. So the number of combinations would be 20 into 19 into 18 into 17 factorial by 3 factorial into 17 factorial is equal to 20 into 19 into 18 by 3 into 2 into 1, which is equal to 1140. That example is most likely harder than anything you'll see on the GMAT math, but you may be asked to find combinations with smaller numbers as well.